All right, good morning. This recording is for Algebra 1, Chapter 6, Lesson 3, Solving by Elimination. We are going to use properties of equality to solve a system of equations. Again, we're just trying to figure out where two lines intersect. We're trying to do it mathematically without having to graph. So the first thing we're going to do is we're going to take our two equations and we're going to line them up so that the terms that are similar, or like terms, are on top of each other. So in this case, 6x and negative 6x, negative 3y, negative 3y, and 3 and 3. The whole point of elimination is to basically combine the two equations, either add them or subtract them, so that one of the variables actually cancels itself out. In this case, it would be 6x and negative 6x, because negative 6x and 6x, when you add them up, give you 0, right? So basically we're adding up this right here, right? Because they're on top of each other. You guys, you know how to add and subtract and do math, from the top down. That's basically what we're doing here. 6x minus 6x is 0. So it eliminates itself, right? It eliminates itself. It is eliminated. It's gone, right? See, it even disappeared. All right. And then we also have negative 3y plus, because we're still adding, negative 3y. Negative 3y plus negative 3y is negative 6y. There it is. And then we also have 3 plus 3, which is 6. So now we're basically left with negative 6y equals 6. And we're going to divide both sides by negative 6, and we're going to get y equals negative 1. Now, Ms. DH, you're saying, where do we get the x-coordinate from? According to you, it's gone now. Well, it's not gone. What we can do is plug y back into one of the original equations, and you can pick. It's your choice. Whichever one you think will be easier on you mathematically, or, just because it's more convenient. It is your choice which of the original problems you plug into, but it must be the original problem. You can't plug into a modified problem. It has to be the original problem. We'll talk about modified problems in like 2 minutes, maybe 3, maybe 4, maybe 5. Anyway, so you have to plug it back into one of the original problems. And as you can tell, I actually picked this one. I plugged into that one because there it is. And the only difference is that the y is now negative 1 because I figured out what y was. Y is negative 1. And now we're going to solve for x. Okay, which means getting x by itself. So let's do some math. 3 times negative 1 is negative 3. 6x minus negative 3 equals 3. Add the opposite. And we're going to have 6x plus 3. We're going to minus 3 on both sides and get 6x equals 0, which means x has to be 0. Which means if I have an x and y, I have an x and y coordinate, which means the point at which this line and that line intersect is the point 0, negative 1. So if I were to graph those two lines, I would see that they hit at the point 0, negative 1. And you can go try it out on SciGraph Cal if you don't believe me. Okay, moving on. There you go. That's the solution. Okay, so word problem. Your class sells a total of 64 tickets to a play. A student ticket costs $1, an adult ticket costs $2.50. Your class collects $109 in total ticket sales. How many, there's not supposed to be a space there, how many student tickets did you sell? All right, the first thing we need to do is assign some variables. Hey, I already did it for you. All right, well, A is going to be the number of adult tickets sold, and S is going to be the number of student tickets sold. The next thing I need to do is start figuring out some equations. First equation is the number of total tickets sold. Well, the number of tickets sold is going to be the number of adult tickets sold plus the number of student tickets sold is equal to the total number of sold tickets. So we're going to have A plus S equals 64. The second equation is the amount of money made off of those tickets. Well, the amount of money made off of the adult tickets plus the amount of money made off of the student tickets has to equal what I've got right there. Right there. So 109. So if one adult ticket costs $2.50 and a student ticket costs $1, it's going to be 2.5A plus 1S equals 109. Now I'm ready for elimination. So I got to line them up. And I'm probably going to subtract here because there's no way I can add 1s and 1s and get 0. But if I subtract, see, subtraction, it's going to actually eliminate. The s's are going to cancel out, right? And then I have 2.5a minus 1a is 1.5a. 1s minus 1s is 0, and 109 minus 64 is 45. So see how everything gets subtracted. You know, this is getting subtracted, that's getting subtracted, and that's getting subtracted. So when you pick your sign for the problem, it has to happen for all of them. Okay, now that I have a by itself, or I don't have a by itself yet, but now I do. A equals 30. When you do the math, a equals 30. So then I need to plug a back into one of my equations. You could have technically picked the second equation to plug 30 back into, but that's a little bit more math than you really need to do, especially when equation 1 is a lot simpler. You end up with 30 plus s equals 64, minus 30 on both sides, s equals 34. So that means that we sold 34 student tickets and 30 adult tickets. That is the solution. But again, if you were to graph these two lines, this is the point. The point would be, 30, 34. If especially like adult was like the x-axis and student was the y-axis, you would get like 30, 34. Okay, I'm sure you can figure that one out. You guys are all really smart. But ask me if you've got questions, because sometimes you have questions even when you are really smart. Okay, so let's move on to the next problem. So sometimes you want to use the elimination method, but the equations aren't originally set up so that you can easily either add or subtract. That's okay. You can modify one or both of the equations so that it will actually add or subtract easily and still eliminate. So here's an example where you only have to modify one equation. Now, obviously there isn't one thing that I can either do to 2 or 7 to get a number that both of them go into. Whereas there's one thing that I can do to 5 to get 15, and that would be multiplying by 3. So the thing is that if you need to change one variable or one term to get it to eliminate, you have to change all the terms for that particular equation. So I'm going to multiply this whole thing by 3. Whole thing by 3. So 3 times 7x is 21x. 3 times negative 15y is negative 15y. And 3 times 17 is 51. So now I've modified this equation so that it works out really well with elimination for my other one. So now it's time to line them up. We'll eliminate now. Line them up. So I moved it over there, and now it's time to add, because 15y minus negative 15y would end up giving me positive 30, and I don't want that. I want my y's to eliminate, which is the whole reason why I modified the equation in the first place. So I do need to add. Now again, if you are for some reason like getting stuff, it is possible, it is totally legit if you multiply an equation, the whole equation, by a negative number, so that it does make it easier to either add or subtract depending on which one you're more comfortable with. I like to add things just because adding the opposite gets me there anyway, if it were subtraction. So I personally like to add, so you'll see me multiply by a negative number at some point later in this lecture so that you can see that multiplying by a negative number is not only kosher, or at least, totally okay, it's totally okay, but then it can allow you to add when some points, if you hadn't multiplied by a negative number, you would have had to subtract. So, personal preference, it is possible, just letting you know. I'll show you in a second. Okay, sorry, sidetracked. All right, so let's go ahead and add these suckers. All right, so we've got negative 2x plus 21x, which is 19x. 15y plus negative 15y is 0, and negative 32 plus 51 is positive 19. Let's divide by 19, and we're going to get x equals 1. Now it's time to plug it back into one of the original equations. Remember the highlighted ones, the ones I just highlighted, those are the ones that are the original equation. This one down here is not an original equation. I'd modified that one. Can't use it. Well, you technically can, but it's sometimes things get a little crazy, I've noticed. All right, but so it's best to always go back with the original equations. So I'm going to plug x back into, which one did I pick? Oh, I picked this one over here, the one that I did modify. So 7 times 1 minus 5y equals 17. And then simplify. 7 times 1 is 7. And then we're going to get y by itself. Subtract 7 on both sides. Negative 5y equals 10. Y equals negative 2 because we divided 10 by negative 5. All right, so that is the solution to the equation is 1, negative 2. That means if you were to graph the two lines, that's the point where the lines would intersect. Good, good. Okay, not too much further, promise. So, okay, so here is the example where you have to modify both equations. There's no one thing I can do to 15 to get 10, no one thing I can do to 10 to get 15, and the same situation for 7 and 3. So I either need to change 15 and 10 into 30, or I need to change 7 and 3 into 21. I'm going to go with the first one. I'm going to go with the 15 and the 10. So I'm going to multiply this top one by 2, because if I'm trying to get 30, 15 times 2 is 30. So distribute, I'm going to get 30x plus 6y equals 18, because you distribute, right? Oops, that doesn't look good. Distribute. There we go. That's how I did it. All right, now I have a positive 30. I need to be able to get rid of a positive 30 by canceling it out. What cancels out positive 30? Negative 30. So instead of multiplying 10 times 3, I'm actually going to multiply it by 10 times negative 3. See how I'm doing that? Because I personally want to have to add. I don't want to have to subtract. So I'm going to multiply by negative 3. Now again, it's your prerogative. It's your choice. I personally do this because I feel it is more convenient for me. You do not have to do it. If you love subtraction, you can go ahead and multiply by a positive 3 and then subtract your 30x's. Totally legitimate. You can do it. I personally like to add, so I'm going to multiply by negative 3 instead. So that's going to give me negative 30x, negative 21y, and positive 12. Now it's time to line it up. Line it up. I'm adding so that I can get rid of my x's. And I end up with negative 15y equals 30, divide by negative 15, divide by negative 15, y equals negative 2. Now it's time to plug it back into an original equation. And again, the highlighted ones were the original equation, not the blue ones, the black and yellow ones. Those were the original. And as you can tell, I picked the bottom one, and it's going to be 10 times x plus 7 times negative 2 equals negative 4. Solve for x. Sorry, it's a little early. Solve for x, and you're going to end up with x equals 1, which means the solution is 1, negative 2. All right, last word problem. Suppose a class sells a brand of gift wrap that costs $2 per package and cards that cost $5 per package. They sell 220 total packages and earn a total of $695. Find the amount of each type of package sold. Well, assign a variable. I may W the gift wrap package and C the card package. And the total number of packages sold would be the wrap plus the cards equals 220. The amount of money we made off of them, if it's $2 per gift wrap package and $5 per card package, that equals $695. Sorry, I'm tired. All right, elimination time. Well, I only have to change one of them, so this is a situation where you only need to change one. Again, I'm multiplying by negative 2 because I want to add. Again, you could multiply by 2 and then subtract. It's your choice. All right. Line them up. The W's cancel out, leaving me 3 card packages equals 255. Divide by 3, divide by 3. It's not the cost, by the way. It's the number of card packages. So the number of card packages equals 85. Stick it back into the original equations, not a modified one. And you're going to get W plus 85 equals 220. That means the number of gift wrap packages was 135. So we sold more gift wrap packages than we did card packages. All right, I'm done. Sorry this was so long and sorry I yawned through it and I got sidetracked. Anyway, bye.